Welcome everyone. Thank you so much for joining us for today's expert webinar on Delta Lake with Azure Databricks. I am Ankita from SpringPeople, India's largest enterprise training provider, and I will be your host and moderator for today's session. We are thrilled to have Mr. Rammohan with us for today's session. Ram is an accomplished SQL Server DBA with over 2 decades of hands-on experience in database administration, design, and optimization across multiple environments. He is proficient in managing SQL Server versions from 2000 to 2017 and excels in database migrations, upgrades, and troubleshooting performance issues. Ram's training background is equally impressive. With a 16-year in the field, he has delivered over 700 batches at leading institutes like MindQ and VisualPath and has also conducted corporate training sessions for industry giants like Capgemini, Genpact, and ICICI Bank. Ram also holds several prestigious certifications, including Microsoft Certified Server Technology Specialist and IT Professional, and is a recognized expert in performance tuning and disaster recovery solutions. Beyond his technical skills, he is deeply committed to knowledge sharing, evident from his active participation in SQL Server forums and mentoring efforts. Throughout the session, please feel free to drop any questions you have in the chat box. We will address them during the Q&A at the end. Without further ado, let's begin today's session. I would now like to invite Ram Mohan to start. Over to you, Ram.
Thank you, Ankita. Hi, good evening, everyone. So myself, Rammohan, as Ankita mentioned, uh, I have around 20 years of experience in the data and AI field. Today, I'm going to deliver the session Delta Lake on Azure Databricks, and we have designed this session in a series. Like today, we are going to cover the background and the overview of what exactly is a Delta Lake, what is the need for implementing the Delta Lake, how the Delta Lake addresses some of the challenges that we are facing when we work with the other types of storage. And in the next session, we are going to work with it practically, how to create the delta tables, how to optimize the delta, and how to perform an operations with the delta tables. So that I think the team will be updating you regarding the schedule of that next series. And today I'm going to start the first portion of the Delta Lake with Azure Databricks. Okay, and as Ankita said, you can feel free to share me. You can feel free to ping me any kind of a questions. At the end of our session, I'm going to address you all your doubts, all your questions regarding to that. Okay. So nowadays, for every business, data has becoming a fuel as a key asset for every organization, and it's very important for us to store the data efficiently. And the main reason the business is lying on the data is we need to provide the data access to the users in some of the occasions. Like you are a customer to one of a bank and you want to check your account balance. You want to check your last 10 transactions. You want to generate your account statement, or you want to perform some of the transactions on your data. So you need to get an access to the data. So in order to see your historical transactions and all, we need to provide an access to the data here. So the main reasons why we need to store all the data is to allow the users to provide an access to the data, one. And the other one is we need to implement some kind of business intelligence over using the existing data, historical data. What exactly is the concept of business intelligence is? We are converting all the raw data into the form of an analysis or the graph so that we will be able to go through that analysis. Like, suppose I'm working for an organization. I want to see how my company is progressing here. How is the sales are progressing? Is it increasing? Is it decreasing? In which month it is going up and in which month it is going down? If I want to track that progress of a data, if I just have the raw data, it will be very difficult for me to track the progress of growth or progress or anything. So for that, I want to use some kind of a business intelligence tools to convert the data into the form of a design, into the form of a graph or a report, so that using the report, I can able to analyze quickly. This is my improvement area, and this is a month my sale is going down. This is a product which has been selling very highly, so we need to focus on manufacturing more number of products like this. This is the area where the people is focused on. So I can able to quickly identify the areas, and I can make some business making decisions. I can take a business making decisions that I need to improve on this or I'm lacking on this. So I will implement certain measures to enhance the sale in that particular area. So every business depending upon this business intelligence as well. And then the other reason for storing the data is we will be using this data for the machine learning. The concept of machine learning is we can use this historical data, we can store all the historical data, we can read this historical data to provide the predictive analysis. If you want to study the historical data and come up with the forecast analysis, like during the era of a COVID, we identified the growth trend of the cases. We study the history of the cases here, and then we are giving a projection here. By this month end, the curve will be flattened. By this month end, these are the states which are going to have the higher number of cases. By this month end, these are the states where we don't have no cases or a minimal cases. The curve will be flattening in this area. So these are the kind of a predictions that we can make. And what on what basis they are making these predictions are based upon the historical analysis that was presented in the form of the data that we stored. And also, nowadays, you might be taking a lot of examples that we are using in a real time. You might be using a portal, Amazon, right? You will be ordering some kind of a products. So whenever you are ordering a product, you are also getting some kind of a recommendation saying that, hey, the customer who bought this product has also looked into this additional products as well. Okay, so how it is reading your mind that suppose if I am going to purchase a television, I need to even look for the stabilizer or a USB, or I need to look for a stand. So there are some customers who already bought this previously. So using the machine learning algorithm, I'm trying to find out what is the pattern of that customer, what are the different products the customer has purchased, the previous customers has purchased. Based upon that, it is going to give you the recommendations. Okay, and also you can take another example. Whenever you are going through book a ticket through IRCTC and your ticket was in waiting list. Nowadays, it is also showing you some kind of an confirmation like there is a chances, okay, like 86 percentage of a chance that your ticket may confirm. So on what basis they are giving you this percentage is based upon the historical analysis. How many times the person who got this waiting list 5, for example, got confirmed. So based upon that, it is giving you the chance prediction that it may happen. So we are everywhere using this machine learning nowadays, even to predict. Suppose whenever I'm trying to book an airline ticket, so it is giving an indication that, hey, if you are planning to book a ticket at this time, book a flight at this time, okay, there is some kind of an airport congestion that has been observed historically. So the chances of the flight delay may be high. The flight chances of flight delay may be low. So it is trying to guide you to avoid the delays. It will be the best flight for you. There are few airline services that are already using this kind of an services as well. So all this is possible because of implementing the machine learning algorithms using the data that we stored historically. Okay, so these are the use cases. If someone asks you like why we need to store the data, as I said, every business is running on the data now. These are the main reasons why we need to store the data here. And we covered it's for mainly three reasons. Sometimes, as per the business requirement, you might be needed to grant the access directly on the data that you are storing. Sometimes you might be using some kind of a business intelligence tools to make some kind of an decision making based upon the data that you have stored historically. And for implementing this predictive analysis, you might be needing to store the data here. Just an overview of what is a business intelligence is. It's a technology or a tool that we can use by the organizations to collect the data, manage the data, and analyze the data. How, as we discussed a lot of examples here, it is going to convert all the data into the form of a graph, summary, or an analysis. So even a non-IT person or even any kind of a person can look into the graph or a dashboard and say that, hey, this is how the business is being performed. Okay, this will always help the organizations to implement the data-driven decision making. Okay, so as I said, we already covered this. Business intelligence helps us to identify the trends in the underlying data. Okay, insights can be determined using this business intelligence, and we will be able to make the data-driven decision making here. Okay, this is an example as we discussed, like if a company is producing around 11 size shoes, okay, and they are targeting mainly the age people. So I can able to keep track like how many pairs has been sold and whether they have been selling high or low. So the company can mainly focus on manufacturing this size. Okay. So this is about the reason why we need to store the data. And now we are going to discuss about the approaches, how we are going to store the data. Okay. So I'm actually covering the background of what is a delta lake. Don't feel like you mentioned the heading as a delta lake, but you are going to some other thing. We are actually coming to the point, that is what drives the need for an organizations to move towards the delta lake here. Before delta lake, these are the different approaches that we are using to store the data. So one of the oldest and a traditional approach to store the data is using data silos. Okay, so data silo is an approach that we are collecting the data and storing the data in each and every segment. Each and every department has its own source of a data. Okay, previously, whenever we are working in an organization, my sales team is going to maintain its own set of a data. My CRM team is going to maintain its own set of a data. ERP team is going to maintain its own set of a data. And the sales team may use a SQL Server for storing the data. And my ERP team may use SAP to store the data. CRM team may use a Salesforce or Microsoft Dynamics to store the data. So I have a different softwares to store the data here. So this approach is allowing each team in an organization to procure their own software and to maintain their own software, maintain the data in their own software. And each team is responsible for its storage and the softwares they are using. And over a time, what happens is it, it develops a kind of a silo. Okay, let me explain you what is a silos. Silos are a completely isolated repository of enterprise data, unconnected to other teams, other repositories, and not available for use by most of the users in an organization. What does it mean is, suppose if I am from a sales team, I'm going to use only the sales data. I will not have an access to the CRM data, ERP data, inventory data, or a marketing data. Similarly, the person from a marketing team, he will have an access to his own database. He will not be able to access the other part of a data. So if we are, as an organization perspective, if we are planning to get a data insight for all the various applications across the organization, since they are completely distributed, they are not connected with each other, it will be very difficult for them to use this approach to get a 360 view of a data of your organization. So this is a main challenge that we are going to face whenever we use this mechanism called data silos mechanism. Okay, and later many companies are moving out of it to get out of the data silos. And there is recently a book also published called End of Data Silos. Okay, so the problem with the data silos are there is a lack of coordination. The same copy may all be also available in CRM team. The same copy is also available in some vendors team. So there is a clash, but all these copies are individual. They don't have any coordination between these copies of a data. They have their own tools and procedures to access the data here. And sometimes it will be end up as a duplicates also. And a lot of problems that we are facing with the data silos, as I said, these are the unconnected dots. No single source of a truth. You don't have one single source of your organization data. It was distributed across different softwares, different databases. So it will be very difficult for us to get a compiled or a combined data from one single source. Sometimes the data becomes stale. Like I have provided a monthly data of the sales to another team who wants to get some kind of a reports requested by the business, but the data is 1 month old data, and the current data is in another sales database. So sometimes you may get a stale copy of a data in one section, updated data in another section, and out of data in a different database we may be ended up we don't actually depend on which copy of a data do I need to reliable. Like we have multiple copies of a data here. And as I tell, like it is very difficult to connect the dots because they are using different softwares, different applications to store the data. And there are a lot of battles over the ownership, like, hey, you owns the data. Can you grant me the permission? You owns the data, so you are responsible for a downtime. So like that, there will be always some kind of an ownership issues. And storage costs are very high because I have to purchase the hardware, I have to purchase an operating system license, I have to purchase a software license for maintaining the data. And there are so many challenges we'll face whenever we are moving into this. We are using these data silos. And we cannot implement an auditing. This is not possible because we don't have single source of it. So these are all the challenges we face with data silos initially. Many companies has come up with an approach. Why don't we use an ETL mechanism? ETL stands for extract, transform, and load. So all these unconnected dots. Let me establish a process to connect to that source of a data, extract the data, do the necessary transformations, and finally load the data into a data warehouse. So data warehouse will become the single source of the data here. And every teams like a data analyst or the BI teams, anyone who wants to access your organizational data, we have a single source of a data now collected from all the different teams of your organization, like the sales team, inventory team, marketing team. We collect all the data and store the data into one single central repository, using which you will be able to perform any kind of your reporting, data-driven decision making, machine learning. Anything can be implemented on the data warehouses here. So data warehouse is a structured data store used for all the analytical data processing and reporting. It usually hold the fully transformed data. Okay, so ETL stands for extraction, transformation, and loading the data. Extraction is a process of collecting the data from varieties of sources. Transformation is a process of converting the data. Sometimes I may be receiving the data in the form of an flat file. I will be converting that data into the shape, into the customer business required format, so that they will be able to generate a reports using that. So that process will be calling it as transformation. Example, if you got a data in the form of a CSV file, I want to convert that data into the form of a SQL Server table and store that in a data warehouse. If I have some kind of columns which are duplicate, I will avoid those columns, duplicate columns. I will implement some kind of a sorting. I will implement some kind of aggregations. I want to convert the data which I received in a raw format into the standard format, into the transformed format, where the business can directly make use of the data to publish the reports or to do any kind of an data-driven decision making. This is a concept of an ETL. And finally, load the data into the data warehouse. Okay, so we'll be creating a lot of pipeline. Pipeline is a process that will be implementing all these three steps: extracting the data, transforming the data, and loading the data finally to the data warehouses. So the data warehouses becoming popular, and there are many ETL tools that became popular during that era, like Informatica, SSIS, DataStage, Ab initio, and there are many other tools which work on this ETL and the data warehouse mechanism. But the advantages with the data warehouse are first, so it's a system to store and manage the large volumes of data, which we are collecting from the disparate sources. It can be called as the organization's data repository. So one single place for all the departments of a data. So anyone can connect to this data and pull up the reports using this data. And it will be helpful for all the data analysts and the BI developers or the BI teams to access the data from the data warehouse. Okay, so mostly the futures of a data warehouse are it is going to store the structured data, the data which we are extracting that will be cleaned first of all. Cleaning in the sense we need to make sure there are no duplicates in the data. And we need to make sure there are no null values, no out of range values, no no improperly formed records. We need to avoid all this process and make sure the data is fully cleansed. And then we will be processing the data using this ETL jobs or ETL pipelines. And that fully processed data will be stored in the data warehouse for the people to access the data here. Okay, some people may have a confusion like what might be the pipeline or a ETL job. So this is nothing but a program or some scripts that we can use to implement this ETL, like extract the data, copy the data, and load the data. We can either design using some GUI in SSIS, or you can write some scripts to implement this ETL process. Okay, and the advantages of the data warehouse are the futures of data warehouse are mostly it can host on premises or on the cloud. It's a phased migration of your legacy data. So if you want to collect all the data from a department, I can get the data on an yearly basis. I can store it in a data warehouse in different partitions, different databases. So whenever wants to access a particular portion of a data, they will be easily able to access the data here. And we will also be able to access the historical data. And the data is fully processed, cleansed. We can rely on the data for business reporting and analytical processing. These are the other features of a data warehouse, like it is mainly helping us in the scenarios like BI and data analyst, and any process that needs to implement an ETL, they can depend upon this data warehouse. Okay, this is how the data warehouse works. We are going to collect the data from external sources and the operational data, and we will be storing the data into collecting all the data from different sources using the ETL pipeline and storing the data into the data warehouse. And on top of the data warehouse, I will be creating this data marts. And all the data will be processed data will be stored in the data marts. This data can be used by the developers, data analysts, MSBI developers, and for the forecast, you will be using this data. And the problems or the challenges with this data warehouse are usually they are on premises. For example, we can use a SQL server for storing this data. The licensing for using the SQL server is a bit expensive. It always couples a compute and a storage. So you need to provision the resources, okay, a lot. So couples means, suppose if I have to increase the number of a processor, I need to increase memory and I need to increase the storage. Okay, I don't have an option to increase the storage because your processing capacity also needs to be increased in most of the cases. Yeah. Again, it depends upon one software to another software, and it can use of proprietary formats. I need to purchase the licensing for using this. Okay, and you need to where it leads to a vendor lock-in means if I'm using a SQL, I will be locked by Microsoft because I already purchased it, the license from him. So I have to use the same softwares and the tools which are released only by this Microsoft here. So these are the challenges of data warehouse. And data warehouses are mainly helpful whenever you have the structured format of a data. In case if you don't have the structured format and you need to work with unstructured format, in this case, data warehouse may not be fit for our operations. Okay, unstructured is we don't have a standard format of a data here. That we can call it as unstructured. And it is not suitable for the use cases. If you want to implement any kind of a real-time data streaming or real-time monitoring, or if you want to implement any data science or a machine learning, structured data may not be a feasible solution for us. In this case, in order to overcome the challenges with the data warehouse, there is a new feature which we implemented called the data lake. The data lake overcomes these limitations of a traditional data warehouse as it is cheaper, okay, and it supports this unstructured data. Any kind of a data can be stored in data lake. So people thought that it will be a replacement or it might be a solution for all the issues that we are facing with the data silos in the data warehouse. Okay, so data lake is a low cost storage systems with a file based API. Okay, it will hold the data in any open file source format. So if the customer is sending the data in CSV, JSON, Parquet, Apache Avro, ORC, so whatever the format you are going to get the data, you have an option that you can store the data openly. No need to convert the data into a different format. You can store the data in the native format in the data lake. And data lake is a centralized repository for all the data. It stores the data in any kind of a format here. It can be a structured data, unstructured data, semi-structured data. Data lake supports all these kinds of a data. And it uses the cheap and reliable storage. So it is not expensive. It is very cheaper. And you can use the cloud storage solutions like Azure Data Lake Storage, AWS S3 as an example for implementing this data lake architecture. And data lake can be used for to store the data in whatever the case your business needs here. Okay, some cases I want to be implementing my advanced analytics, machine learning, data science, BI, anything can be implemented using the data lake here. So advantages of this data lake are we are able to successfully eliminate the silos with the help of a data lake. We can even write some kind of a SQL queries and implement the data science by using the machine learning algorithms. And we always think of the cloud first and cloud only. Suppose you want to build your applications on the cloud, and this is the best solution that you can use a storage in the cloud itself for storing all your organizational data in the cloud. And you can even migrate your on-premises data to the cloud with variety of tools we have. And it is also keeping track of the data, the historical events, and you will be able to handle the real-time streaming data as well. So these are the advantages of data lake. Some scenarios, not the complete scenario, streaming will be supported up to some extent. So you need some kind of an access control, like data lake can be protected using secured using different mechanisms like IAM and RBAC mechanism, or we can implement some kind of access keys, shared access keys, and using the ACL mechanism, we can control the access on the data lake. And even we have a flexibility that we will be able to implement some kind of a searching functionality using the index tags to quickly identify. Suppose I have thousands of files, and if I want to quickly locate one single file, we can able to locate it using this search tools and the metadata tags. And this is how the data will be stored in a data lake. So whatever the data that I am collecting, either it may be a structured data, unstructured data, I will be initially staging the data in the data lake, and then I will be performing the transformations. So this approach, previously we discussed about ETL. We are first extracting the data, transforming the data, and then loading the data here. But in this case, we are doing the ELT mechanism. We are extracting, collecting the data from varieties of sources, storing the data in the data lake first, and then we will be performing all these transformations, cleaning the data, making the data ready for the business, And then that data can be used by the machine learning and the reporting purposes. So the challenges with these data lakes are it slow down the BI and analytic task because the reason is first you are loading the data and on top of that you are doing all these transformations. So this will impact the performance. It's very difficult to set up and manage, and we have to face a lot of performance issues. Reading the data, making the transactions on the data is a bit performance. It may cause a lot of performance issues since it is not associated with any schema, any structure. In order to locate the data to perform an update, a delete, it will cause some kind of an performance issues as well. And it will not support the ACID transactions. We are going to cover what is an ACID is. So that's another drawback we used to face. Because we don't have ACID, it may lead to the data consistency issues. So on a data lake, we cannot rely on the data because the data is sometimes not consistent. It may lead to the unreliable data swamps, which means the data is not consistent. Okay. So data lake, as we discussed, it's a central repositories to store all the types of a data. Okay. So I am trying to explain what are the challenges that we have with data lake in terms of consistency. I'm mainly focusing on consistency here. And you need to understand how data lake can be used in the big data world to perform the read and write operations. How data lake fail to provide the consistency whenever multiple users are trying to access the same data at the same time. So I want to give some of an example so that you will be comfortable and able to understand what are the real-time challenges with the data lake. And then those challenges will be addressed by the Delta Lake, which is our main concept. So how Spark writes the data to a data lake? Okay, so in Spark, if there is a job to process my sales data, it is going to, in Spark, the advantage of a Spark is it uses the in-memory process. It stores the data in memory and it implements the parallelism by partitioning the data into multiple small chunks and process all the data parallelly. This way, it will enhance the performance of my operations. Suppose if I have to process the sales data in Spark, this will be divided into multiple tasks. Task 1, task 2, task 3, and task 4. And the data will also be distributed across these multiple threads. And all these threads will be executed parallelly. So the result of a sales data, whenever it is storing in the data lake, it will be stored in the form of a partitions. My first part file, second part, third part, fourth part, all the CSV. Instead of storing the data as one single file, it will create some kind of a partition files and load the data into this multiple partitions here. Okay, so here is the problem. Here is the challenge we face with the consistency. So as I said, if you want to maintain the consistency, you need to ensure it follows the ACID properties. ACID stands for the atomicity, consistency, isolation, and durability. It guarantees the consistency of a transaction here. Okay, so each transaction in database provides the ACID guarantees. But what about the delta? What about the data lake? Okay, so let me explain you the concept of the ACID properties. As I said, A stands for atomicity. It means it guarantees the transaction to be consistent by following this approach. Atomic means either the transaction should be fully committed or the transaction should not be committed at all. This is the concept of atomicity. Consider I have a table, employee table, with three columns: employee ID, name, and a salary. So I already stored three records into this table. And whenever I'm trying to insert the fourth and the fifth record, due to some problem, my transaction got failed. Okay, if the user is trying to access the data, since there is no mechanism to validate whether the transaction was successfully done or the transaction got failed, still the user is able to access the failed records as well. Okay, suppose if the fourth record is already inserted, fifth record got failed. Okay, so the user is able to access the fourth record. And consistency, there is no consistency like a database. Consistency check that can be implemented like a database. Okay, say for example, consistency stands for your data always remains in a valid state. Suppose I have designed some kind of a constant like a database. Say my balance should never go below a zero. Okay, suppose I have an account balance 100. If someone tries to withdraw 200, okay, it should not accept. This is the consistency. And then if you want to discuss about isolation, isolation means independent. Whenever multiple people tries to access the same portion of a data, it behaves like, it feels like each and every transaction is independent. One transaction should not control the other transaction here. One user should not wait for the other user to complete the transaction. Especially whenever this reader and writer process are running parallelly. The reader has to wait until the writer process is completing its operation, or the writer has to wait until the reader process is completing its operation. So isolation is a mechanism that will help us to balance the consistency and the concurrency for a set of transactions that we are implementing. So ACID properties guarantees that isolation level as well. And durability, it means once the data is committed, it will be stored permanently. Even my system crashes, I should be in a position to recover the data fully without any data loss. So these are the properties of ACID. Okay, and how this ACID properties works with the data lake. Data lake cannot guarantee these ACID properties. So we may be always, if we are using the data lake, we may be getting into the situation where the data is not at all consistent. So first issue with the acid properties. I'm giving you a few case studies so that you will be able to understand what are these acid properties are. So whenever I'm trying to append the data, see, I already have the part file 1, part file 2. I am trying to append another 2 files into the same sales data and trying to store these 2 files into the data lake. So the part 3 was successfully loaded into the Delta Lake, data lake. And then while I'm trying to append the fourth part, write the data, it failed with some connectivity issue or some other error like divide by zero or some error. It failed to load the data into the data lake. And whenever the user is trying to read the data, he is able to read the data which is partially loaded to the data lake. As per the atomic property, if the transaction got failed, both the files should be rolled back, or both the files to be committed. Part 3 and part 4 should be rolled back, or part 3 and part 4 should be committed. If it is successful, both will be available in the data lake. If it is not successful, it should not be having part 3 also. But whenever the user is trying to read the data, since there is no such validation, user will be connecting to the data lake. He sees that there are 3 parts and they are able to read all the 3 parts here. So this data lake, it is breaking these 2 properties of an acid mechanism. One is it breaks atomicity and it breaks a consistency as well. So this leads to an inconsistent data, okay, which is not fully committed. It's a partial data, not a full data. But data lake is able to read that partial data as well. Leads to inconsistency. Another situation. Suppose if there is a job failure while overwriting the data here. So in this case, what happens is, suppose there are 2 part files which are already there, and then you want to overwrite 2 more files. This is how the overwrite actually happens here. It deletes the first 2 files and it is going to update the 2 files with the latest data. So here the first 2 files are already deleted. And whenever you try to insert the modified data with the overwritten data, the part 1 file is loaded and part 2 file has failed due to some issues, has failed in the middle. It results in the partial data loading. And whenever the reader tries to read the data, it reads this part file 1, which has the inconsistent data here. So this is breaking again the atomicity, consistency, and the durability. What is a durability is once the data is stored, it should be stored forever, even in the event of a system crash as well. But as a first step, I deleted these two files manually and I tried to overwrite the two files with the latest data, updated data. But because of some issues, only part file 1 was loaded and 2 failed to load because of some issues, causing the inconsistency issue. So the previous data is lost. And considering another example here, if you are performing read and writes at the same time, okay? So I already have the part file 1, part file 2. I'm trying to add two more part files, okay, into the data. So part file 3 was written and part file 4 was still in the process of, so it's not committed yet. And this user is able to read the data which was half done. The transaction is not yet committed. So the user is able to, the reader who is trying to read the data is even able to read the inconsistent data which is not yet committed. So again, this breaks this consistency and isolation. And appending data with a new schema, like already I have inserted two part files with 3 columns. And if you are going to add two more part files, which have 4 columns, so there is no schema validation to check how many columns we have in a particular file. So the new files we received, it has 4 files. No schema validation is being performed. So if it is a data warehouse, there is a strict schema validation. If you are defining a 3 column, you have to insert the data only into the 3 columns. You cannot insert the fourth value. It fails whenever the column values are mismatching. If you are defining a column type, the data type, that it should be an integer, you have to just insert that integer value. Other than an integer value, it should fail. But in data lake, we don't have any such feature. So resulting, my data which is available in data lake, it have few columns, few parts it has 3 columns, and few parts it has 4 columns. So it leads to an inconsistency issues. So these are all the challenges we are facing whenever we are using this data lake. So you can see the data reliability issues. Whenever there is some data corruption happens because of a failure, there is no rollback of the inconsistent data, no rollback of the failed data. It leads to the data inconsistencies. There is no data validation, schema validation, whether there are any duplicates, whether you are trying to insert only a few columns, whether it create any kind of a null values. We don't have any such data validation. So it may result in causing the inconsistency issues. And since there is no ACID transaction mechanism, we have the issues while reading the data, inconsistent data. Okay? And it's very tough to handle. It has a support to handle the streaming data, but you cannot combine together the batch mode ingestion and the stream mode ingestion. And it is very difficult because you store the data in a file format and it does not support these ACID properties. It will be very difficult to update an existing file, delete and merge on the files. And we are facing a lot of data quality issues. As I told you, there is no schema validation. So whenever you are just storing a data with a file, that file may have 3 columns or 4 columns. There is no validation of a columns here. And we cannot apply the checks on a data as well. Okay, and the other drawbacks are lot of query performance issues because it stores the data in the format of a file and there is no log in understanding what changes has been done recently or how to track the changes. We don't have any such mechanism, so it will be causing a lot of performance issues as well. It will be difficult to maintain the historical version of a data using the data lake. So this is our main key area. That's where the Delta Lake came into play. Delta Lake can help us in avoiding all the problems that we are facing with data silos, data warehouses, and a data lake. Okay, we came up with a new solution to avoid all these problems called a Delta Lake. So Delta Lake is an open source storage layer that brings the reliability to your data lakes. Okay. So for example, if I'm going to store the data in a Parquet format, Parquet, for the people who are new to it, we can store the data in a column format in Parquet. So if I'm going to store one data frame, it will be breaking the data frame into the form of multiple Parquet files, Parquet partitions, and it will load the data into Delta Lake. I'm just comparing how the data works with the Data Lake and the Delta Lake. Okay, so I'm going to store the data in the form of multiple Parquet files. If I'm going to store the data in a Delta format using Delta Lake architecture, there is a small utility that you need to install on top of a Spark engine. And whenever you are going to store the data in a Delta format, it's similar to the Parquet file. Whatever the data frame that you are going to store in a Delta format, it will be maintaining the same partitions, 3 partitions to store the data. Till here, everything is the same. But the additional advantage we have is there is a new feature which is magical, which brings a lot of changes. To avoid the consistency issues is it also provides you a transaction log to track each and every change that you perform against the data lake or the data that you stored in a data lake. So it is very easy for us to track the changes and to query the changes and to perform the consistency on the database. It brings the reliability to the data that you stored in a data lake. Okay, so just an example how we can store the data. If you want to store the data in a Delta format, we can use this syntax called dataframe.diet.format, just like we are using it the same format for CSV, JSON, Parquet. Similarly, we can also use the same function, dataframe.write.format, delta, and then you can use the same and specify the file path, the meta store, the directory name, the path where you want to store the data inside your Delta lake. So it will store the data in the Delta format. Okay. So let me give you some examples to understand how the transaction log helps us in bring the consistency. What does the transaction log actually consist inside the Delta Lake architecture? So whenever we are performing this write operation, for example, initially, okay, I have the sales data in a folder. I'm going to create a subfolder inside the same data lake with the name as delta underscore log. So if I have stored 2 files initially, once these 2 files are stored, one operation is completed successfully, it is going to generate one JSON file which has an information that add part 1, add part 0, add part 1. 2 files are successfully loaded. And then another user is performing another write operation to append another partition file. So part 2 is returned to the folder first, and then it is also maintaining a log saying that there is another JSON file 001 is added to the subfolder containing the information about what kind of data has been added to your main folder. And then whenever user added another file, it is going to add that file first of all here, the partition file here, and then it is going to maintain the log. Once the JSON file is generated in the subfolder, this is an indication that your transaction is completed. That append operation that you are performing or the write operation that you are performing is successful. Okay, that will be measured with the generation of this JSON file. In case like the previous examples we discussed, if my files got failed in the middle, okay, I'm not able to complete a transaction, then this JSON file will not be generated. So for every write operation we are performing, the part files will be written first and a transaction log file is added to this delta log folder in JSON format. Okay, and this is how the write operations are performed and how the read operations are performed in Delta Lake. So whenever if some user wants to read this customer data from the folder, first step, it will go to this delta log. It identifies the JSON file. It reads the JSON file and find out 000.json. It will have two partitions. Okay, let me read these two parts. And then it will have another one. It reads this another file. Okay, so first the transaction log files are read first. Based upon the information present in the transaction log file, it will identify what changes has been done to this customer folder, and it is trying to read the data from a customer folder, the main files here. So this is how the read and write operations happened in the Delta format. Okay, so you can see the same things here. It is going to how the information will be recorded in a transaction log file, a bit more complex to make you comfortable with what exactly the transaction log looks like. What kind of information does it record inside the transaction log? Okay, so whenever I'm going to create two part files, for example, I have a information being stored for a table. I'm dividing this information into multiple parts, ID and name, and I store the part one, part two, and on the log file, it will record the information like this. Add a new partition and add another partition, part one and part two, and a JSON file is created with this information. And then when you are trying to insert another file with 5 and 6 records, once this insert operation is completed, it says a part 3 file has been added. So this JSON1 will have an information related to part 3. It will record the information like what operation are you performing here? Are you adding a new partition to it? Are you removing an existing partition? That will be specified in this operation and the file name that we are actually adding or removing from it. And in case of an update operation, suppose I want to change a value where A can be changed to AA. So in this case, what we are trying to do is, so all the unmodified rows in the partition 1 will be copied. 2 is unmodified. So I will be copying the 2 as it is. And then I will be updating this first record here, okay, as 1 as AA. So the log will be recorded like this for an updated operation. So remove the part 1, okay, because all the records which are not modified has been moved from part 1 to part 4, and add part 4. The part 4 was updated with the new value. So it is going to write the log for an updated transaction. So this way, this is to give you an idea of what the transaction log generally stores internally for every operation that you are performing against the delta. It is going to keep track of all the information. Every operation that you are performing, we have the log that is generated. If the log is generated, that's a confirmation that your operation is completed. Otherwise, your operation is not at all completed. Okay. So if you want to read some more examples, you can see here, whenever it tries to read that information on the same data that we have shown using a read file, it will go to this JSON1, JSON0, JSON1, JSON2 first while reading the data. And in this, we said read the data from 1 and 2, okay, and 3. And finally, the 2.json is saying remove part 1 and just add a part 4. So it is going to read the data from part 2, part 3, part 4. Since we already mentioned that remove part 1, it is not going to read the data from a part 1 file here. So that's how the transaction log is helping us to read only the consistent data. Okay? So this is how the data looks like. So the futures of Delta Lake are, we can avoid all these inconsistent issues. We can guarantee the data consistency while you are performing a simultaneous operations. And the few scenarios what we discussed will also be covered now. It will also guarantees the insert, updates, and deletes can be performed. I have shown you a few examples how they can be implemented. We can also enforce some kind of a schema, and we can also implement some time travel. So historical changes, if you want to review, we have a log file to review the historical changes. We can also combine both the batch and streaming data together. We can implement a lot of data consistency checks, and we can also implement the statistics. These are the things that I'm going to cover in the next session, which will be scheduled probably on 14th, and I will explain all the things by doing it practically in the next session. Okay, and just let me complete this. As we already discussed about an acid part, the four scenarios what we discussed with data lake, and we are facing some challenges, consistency issues with the data lake, how we can overcome the challenges with delta format, delta lake. Suppose I have two files, it already created a JSON file for it. If you are trying to add one more partition file, okay, two more partition files with an operation, and unfortunately the job got failed in the middle. There is no log generated here, okay, because the log will be generated only if the operation is successful. Since my operation got failed in the middle, only one part has been loaded, the other part got failed, the log will not be generated. And since there is no log, whenever the user is reading the data, it is just going through the log, the old log which is available, and they are trying to read only the part 1 and part 2 file. They will not be able to read this part 3 file at all. So this way, your data remains consistent. Second example, job failure when trying to overwrite the data. Okay, so in Delta Lake, previously what we discussed with Data Lake is the old files will be deleted and new files will be overwritten. Here, the existing files will not get deleted here. So same, I have part 1, part 2, and we have a log for it. And whenever you are performing an operation with part 3 and part 4, unfortunately, it fails in the middle. And whenever you try to read the data, it tries to read the data which is already consistent, which is not changed. And it is not able to read this data which is in pro. So your changes are consistent again. And it is also making sure you are not going to lose any data. And simultaneous read and write operations. Whenever you are performing these operations, okay, like if I am trying to write the third file and fourth file is still getting processed, okay, it is not going to generate the log for that. It is only generating a log for only the JSON file here. Okay, or this is in progress. So whenever I'm trying to read, I will only read this data. I will not be able to read this part file and part 3 and part 4 until my operation is completed fully. So no dirty reads because the operation is still in progress. If the operation is completed, I might have get this 001.json. If this is done, if the log file is created, it means the transaction is completed. So then if I go to perform a read operation, I will be reading this JSON and this JSON so that I will be able to read all the four parts. Otherwise, I will be reading just the consistent part, the 1 and 2, not this 3 and 4. So this way, I will be even preventing the dirty read operations whenever simultaneously write and read operations are happening against my data. Okay. So this is all we have at this point of a time. Okay. This session is to address how Delta Lake helps us to eliminate the consistencies, and Delta Lake is cheaper in terms of implementing the storage, highly scalable, and it provides a transactional consistency and data reliability, prevent the data consistency issues. That's all we discussed as a part of the first session of the series. In the next session, we'll practically see how to implement the Delta format, Delta Lake, and then how to discuss about more features with the Delta Lake.
Thank you, Ram, for sharing such valuable insights with us today. It was certainly a very informative session for everyone, and I'm sure everyone here learned a lot. For those interested in expanding their knowledge further, especially with Azure related courses, do check out our special discounted batches of virtual instructor led trainings on our website, springpeople.com. You can take online VILT courses from the comfort of your own space with flexible scheduling. And if you're looking for private, more customized batches, we'd be happy to discuss those options as well with you. For those with tighter schedules, our self-paced courses offer a flexible and affordable alternative. For more details, feel free to reach out to us at training@springpeople.com or call the number displayed on the current slide. As we are nearing the end of our time, we'll need to wrap up the live session here. Any we also I want to mention we are ending series 1 of Delta Lake with Azure Data Bricks today, but the journey doesn't end here. Join us next Thursday, which will be 14 November 2024, as we continue into the next part. If today's session sparked your interest, we'd love to see you back. Thank you all for joining us today. We truly appreciate your participation and will be sharing the webinar recording with all attendees soon. Before signing off, we kindly request you to provide your feedback, which will really help us improve the quality of our upcoming sessions. So please take a moment to let us know how we did. On behalf of Spring People, thank you once again. We look forward to seeing you at our next expert webinar. Goodbye and take care.